Hello everyone, in this video I will discuss some examples in which we will use the first derivative test. So we will do some maxima and minima problems. So read the first example, take a moment, and if you want you can pause the video. So we are given this function and we need to use the first derivative test to find the values of x where fx is increasing. So let's start with the first part. Find the values where fx is increasing. So first step is we find the critical values. And in order to find the critical values, what we do, we set our first derivative equals to 0. And since the function here is x cubed minus 3x squared, so first derivative would be 3x squared minus 6x, and we set that equal to 0. So this implies, so we can solve this equation. So 3x is a common factor, x minus 2. So product of two factors is 0. Actually, three factors is 0. It means one of them should be 0. Since 3 cannot be 0, so either x is 0 or x minus 2 is 0. So it means either x is 0 or x is 2. So thus our critical points are 0 and 2. So now we're going to make a table in which we're going to decide our signs of the slopes, and also we're going to decide about the behavior of the function, whether it's increasing or decreasing. So in the center we write our critical point. So our first critical point is 0 and then we have 2. So on the left of 0, so if we think about the sign of our derivative. So our derivative function is this one, right? So our derivative function is f prime x is equal to 3x squared minus 6x. So if you put a negative value which is on the left of the 0, so we can choose some value. So let's choose -1, and on the right of 0 you can choose 1. Similarly, on the left of 2 you can use 1, and on the right of 2 you can use 3. So basically just take the values on the left and right of each critical point and then decide on the sign. So if x is -1, so 3 plus 6, so that is going to be 9. So the sign of slope is positive. Similarly, if x is 1, so 3 minus 6, -3, the sign is negative. If x is equal to 3, again, the sign is going to be positive. So sign of our derivative we write on the first row. In the second row, we decide on the behavior. So positive slope means the function is increasing. Negative slope means the function is decreasing in that interval. Again, positive slope means the function is increasing. And from here, we get some ideas about the function. So first increasing, then decreasing gonna look like this. And first decreasing, then increasing gonna look like this. So here we get a maxima. So I'm just doing all the discussion here. So we get a local maxima at this critical point, and we get a local minima at critical point 2. So let's answer our question. So first one is values of x where fx is increasing. So fx is increasing in the interval from -infinity to 0 and then from 2 to infinity. So fx is increasing for all the x less than 0 and all the x values greater than 2, or in other words you can say it's increasing from -infinity to 0 and 2 to infinity, or you can use the union sign if you want. So as per our discussion, the maxima happens at the critical value when x is 0. So it means the relative maxima would be, so value of the function at 0. So remember, we're gonna put the value in our original function because we are looking for the maximum height of the function. So when x is equal to 0 at that time, so we get 0 cube minus 3 times 0 square, and that value is 0. And similarly, if you are looking for relative minima, so relative minima happens when our critical value is 2. So in that case, we have 2 cubed minus 3 times 2 square, which gives us -4. So thus from here we get the maximum point is 0, 0 and minima point is 2, -4. So this is our relative maxima and minima of the given function. So based on what we did in the previous example, I'm going to discuss our first derivative test summary. So the first step is find the derivative of the function and then find the critical values by setting the derivative equal to 0. Also find the values where derivative does not exist. So those will be our critical values. And after we find the critical values, we're going to use our table method. So we're going to set up a table where we're going to write the critical values here, and we're going to choose some test points on the left and right of the critical values, and we're going to check what is the sign of slope and what is our function's behavior, whether it's increasing or decreasing based on the sign of the slope. So easy test points, choose that, and then in the end, so if the slope changes from positive to negative, then we get a point of relative maxima. If slope changes from negative to positive, then we get a point of minima. And if the test point does not change sign, so neither we have a maxima nor we have a minima. So this is our first derivative test summary. So let's do one more example and use this test summary there. Find the maximum and minimum values for this function. So first step is find the critical values. For that, we're gonna figure out our derivative. So derivative in this case would be 9x squared minus 12x, and then set that equal to 0. So set first derivative equals to 0. So this implies 9x squared minus 12x equal to 0. And let's try to solve this. So in this case, 3x is a common factor. So inside we are left with 3x minus 4. So product of these factors is 0. It means either x should be 0 or 3x minus 4 should be 0. So x equal to 0 or 3x equal to 4, which implies x is equal to 4 over 3. So now we have to decide whether these critical values are the points of maxima or minima. For that, we're going to set up our table. So I'm going to write my critical values here. So our shorter value is 0 and the other value is 4 over 3. So one point on the left of 0, just choose any point. So I'm choosing the most convenient one would be -1. Similarly, I'm going to choose the point on the right of 1, which would be 0, which would be 1. And similarly, we're going to choose something bigger than 4 over 3, which would be 2. So if you are comfortable with some other points, feel free to choose any points that meet the criteria. And then we decide on the sign of f prime x. So 9x squared minus 12x. So first I'm going to put -1 here and I'm going to see what the value is, whether it's a positive value or a negative value. So we get -9 minus, so 9 plus 12. So overall we get a positive slope. Similarly, you can check at 1. So that would be 9 minus 12. So it's -3. So we get a negative value. And if I put number 2, so again I get a positive value for the slope. So slope is positive, so that means the function is increasing here. Slope is negative, that means function is decreasing. Slope is positive, means function is increasing. And if we draw our function like this, from increasing to decreasing and decreasing to increasing, so we clearly see that we get a point of maxima at our critical value 0, and we get a point of minima at our critical value 4 over 3. So thus the maximum value would be, so maximum value would be f of 0. So just plug in the original function. So that would be 3 times 0 cube minus 6 times 0 square plus 4. So f of 0 is equal to 4. So that's the maximum value of the function. And if you want to find the minimum value, so that would be at the other critical value 4 over 3. So we calculate 3 times 4 over 3 cube minus 6 times 4 over 3 square plus 4, and that gives us 4 over 9. So this is our minimum value of the function. So these are our required solution. We found the maximum value of the function and we found the minimum value of the given function. I hope that makes sense. So in short, for the first derivative test, we find the critical values by setting our derivative equal to 0, and then we check in the neighborhood of the critical points. So if the slope changes sign from positive to negative, we get a point of maxima. But if it changes sign from negative to positive, we get a point of minima at that critical value. Thanks for watching this video. In the next video, I will discuss an example for curve sketching, so make sure you watch that video as well.